I am Bulelani and I'm going to teach you today how to answer some few graphs questions. We need to plot them. And remember, the aim for us when we are answering this question is to look at the equation and know exactly the type of a curve that you should draw. Number one, the question says, sketch the graph of y is equal to square root of 9 minus x squared. In this case, you can see that that square root does not have a sign. If it does not have a sign, it means it's a positive square root. That means that is a semicircle. For semicircles, if it's positive and it starts with y is equal to something, that means it is an upper semicircle. So when you are drawing your Cartesian plane, you will draw it such that it fits on top of the x-axis. So let's look for the intercepts, because those are the things that are important in these curves. For the x-intercepts, we'll get plus minus 3, and then for y-intercept, it will only be positive 3, because the formula itself is showing us that we should only focus on the positive side of y. Now, this curve, by nature, it is a little different from the circle because it is a function. When we are using the vertical line test, we will notice that it is cutting the graph only in one point. So if it does that, that means our curve is a straight line. So that is how we will be able to draw this curve, and it is a function in terms of features. The second question is asking us to sketch a graph of 4x squared minus yx squared, which equals to 36. By looking at this curve, you might think that it is an ellipse, but it is not. Instead, it is a central hyperbola. So for central hyperbolas, or even for ellipse, in fact, the first thing we do is to divide by that 36, which is on the other side, to get the x and y intercept, because there are three things that are very important in a graph. Number one, the intercepts. Number two, the shape of the graph. And number three, the general form of the equation of the graph. So this is what we are going to do now. We'll look for the intercept, so we'll put it in an intercept form. Then after that, we'll look for the intercepts. And for this type of a curve, we'll only have x-intercepts. The y-intercept will not be available because we have a negative before y squared. So we will end up going into an imaginary form, and we do not want imaginary things here. We are talking of real numbers. So that is what we will see. Sketch the graph of y is equal to negative x squared plus 2x plus 3. As you can see, this is a parabola by nature. It is the nature. So this one, it has a negative a value. So the a value, if it's negative, that means it is a maximum. For x-intercept, we need to make y to equal to 0, and then we solve. You can either solve using the quadratic formula, or you can choose to use factors. Here I am using factors. As you can see, we look for the factors for the first term and the last term. For the first term is negative x and x. For the last term, it will be 3 and 1. Now, the positioning of 3 and 1 must be such that they form that positive 2x. So how do they do that? We'll have negative x plus 3 and x plus 1. Then we can now find the x-intercepts by equating each bracket to 0. Then after that, we look for y-intercept. Y-intercept is always the value of c. So that means y is equal to 3. Since we know that this is a maximum turning point, when we draw our curve, we will draw it following the maximum, and then we can locate each intercept in this way. The next thing, it will be to look for the axis of symmetry in order for us to find our turning point. So let's go ahead and do that. we are using the formula for axis of symmetry, which is x is equal to negative b, and the negative b for us, it will be that 2, the middle term, and divide by 2a. Remember, our a was negative, so it's just negative 1 for a. Then we can substitute and notice that axes of symmetry are at 1. Then the turning points, we will just substitute by that 1 to the original equation, which will give us negative 1 plus 5, which is just 4. So we can put the values of turning point as 1 and 4. As we usually teach you, when we are drawing the curve, the critical values are the turning points, the shape, that's where you get the marks, and also the name of the curve. So you need to label your graph. The range for this curve is from the turning point. So the turning point is pointing downwards, so it's a maximum turning point. Therefore, when you write it, you'll just write y is less or equal, y is less or equal to 4, and also should keep in mind that y is an element of real numbers. That will be our range. The next question says, sketch the graph of x, y is equal to negative 3. The moment we have that negative 3, we know that this is a negative hyperbola, because that is a form of a hyperbola. The rectangular hyperbola that is negative will only be on the second and the fourth quadrant, and we will draw it like this. Then it is broken, or it is a discontinuous form, because you can see that you cannot draw it without lifting your hand. You are forced to lift your hand. Those are part of the features. The things that are important when you are drawing this is the shape and the labeling of the curve. As you can see, I just did that. Now, I'm sure those who did N1, they quickly recognized this curve because they've been doing it all this time. Now they are saying sketch the graph of y is equal to cot x. Then they gave you the domain. We will draw it from negative half pi all the way to positive half pi, meaning that is negative 90 all the way to positive 90. Now, when we are drawing a cot curve, remember it is an inverse of a tan curve. A tan usually starts at 0, but a cot curve will start at 90. So that is how it will look. Honestly speaking, I do not know when do we have to use this curve. If someone knows where maybe they are using it in an engineering field, maybe music, but I would like to know where do we use these curves so that we can relate sometimes with real life situations. Then we are asked here to sketch the graph of 4y squared is equal to 36 minus 4x squared. So we can first rewrite it nicely so that we can be able to divide by 4, and then we divide by 4 on both sides, and then we'll have our radius. Then it will say the radius squared is 9, so that means the radius is actually 3. Then we'll be able to draw this curve because we have our intercept, because the radius is the intercept basically. So it is intersecting the curve on plus minus 3 in both axes, x and y. Then after that, you will label the curve, because we said that we have 3 things you should do in a graph. Number 1, you should have the correct shape, intercept should be there, and then we will have the formula or the label of the graph. It should be labeled. The next question says, sketch the graph of y is equal to 2 raised by exponent 3x. Now, this is an exponential graph because we have 2 raised by 3x, so that means it's an exponential graph. How do we know it is an exponential graph? The focus for us will be on the x. So if our x is an exponent, that means the graph itself, it is an exponential graph. So the exponential graph is drawn in this way. It always intersects at 1, and then you have its shape, and lastly you have to label it. So that is how we solve or we draw an exponent graph. Don't try to have a table. We don't need tables anymore now. Just go straight to those three things. Just make sure the shape is correct, the intercept is there, and the formula is also there. Then we have a follow-up question for this. They are asking us if this graph is continuous or not. Oh yes, it is continuous, because you do not lift your hand when you draw it. That's how you know it is continuous. When you don't lift your hand when you're drawing your curve, you are sure it is continuous. Now we are asked to sketch the graph of y is equal to 2 sine x. Then they gave us the range from 0 all the way to 360 degrees. In this case, they used degrees. In the previous case, they used radians. So when they are using radians, you will see pi. But when they are using degrees, you will see, of course, the degrees, because degrees are the ones that I'm sure most of you already know them. If it's set at 0, then we can put our axis like that, and then we can start to draw. That 2 is our amplitude. So amplitude is 2. That means it will be those turning point for our graph, positive 2 and negative 2. Then we have turning points when we are seeing 90 degrees and also at 270 degrees. So this is how you will draw it. It's a sine wave. Sine wave is very well known. It's everywhere. It's practically everywhere. There are many things in music, you see it in engineering, you see it in different fields of engineering, and also this wave is very, very, very normal. It's used in real life situations a lot. The next question says, sketch the graph of y is equal to ln x. Now this graph is the same as log base e of x. So that means it is a log graph. For a log graph, you just have, the nature or the shape of a log graph. So we will look at the shape of that log graph and then implement it, knowing that the coefficient of x is 1. So if the coefficient of x is 1, that means our curve will be having an x-intercept at 1. If the coefficient of x, for example, was 2, then our x-intercept will be a half, because you always divide by the coefficient of x. Now let's move to the next curve. It's also a trigonometrical function. We are asked to sketch the graph of y is equal to sec x between 0 and 360 degrees, which is the same as 0 and 2 pi if they asked us using radians. So for now they are using degrees, so we'll just stick with degrees. Also this curve, honestly, I don't know where in the world are we going to use it, but we are asked to draw it, so let's go ahead and draw it, even though I got no idea where to use it in real life. But if someone knows, please just tell us. It's not very, we are not too old to learn. We always learn something. So we are growing, but we are always learning. That's growth. If you are growing and you are not learning, you are not really growing. So for us, we do embrace learning. So just inform us, tell us where you've seen such curves being used, then we will have better understanding now. Maybe that will even motivate us further to know about these curves, because some of the people, the reason they don't really care about some curves is because they do not know where are they applicable. But the moment you are full of knowledge, When you know a curve, how it works and why it is used, then it will give you that edge, Some people, they call it enthusiasm. So that edge, that desire to know better. So that can also motivate us to really know and understand these curves. So for now, since we really do not know it, we are only learning it to pass. We are not learning it looking at the future per se. So this curve looks like this. It's a very funny looking curve, but it is good for you to give you some marks. That is 3 marks. So we do have intercepts, turning points. Turning points are important, and then you can also label your curve. That's what we do. The question is asking us to sketch the graph of y is equal to 10 divided by x. This again is a hyperbola, a rectangular hyperbola. This time it is a positive rectangular hyperbola, because if our cosine is positive, it will be on the first and on the third quadrant. Again, it is a discontinuous function. It is a function because when you put a vertical line, it will cut the graph in one point, and it is a discontinuous function because you are forced to lift your hand in order for you to complete drawing it. You cannot just draw it without and finish it without lifting your hand. Then the follow-up question is asking if this curve is continuous or not. So looking at the features, you can obviously tell me if it's continuous or not. Thank you. The next question says, sketch the curve of y minus 3 is equal to x squared. Okay, obviously we have x squared. That means that's a parabola, and that x squared is positive. That means it has a minimum turning point. So let's start to draw it. You'll notice that I am using 2 colors. I'm using a black color and also a blue color. The black color, just take as if it is your pen, and then this blue color, it will stand for your pencil. Every time you are drawing a graph, you can use a pencil, but every time you are doing calculations, you need to use a pen. There are people who do not read instructions. This is written in the first page in your answer book. In your question paper. You need to know when to use a pencil and when to use a pen. If you write using a pencil, you will not awarded marks because the instructions are clear in a black and white paper. Sure. Now we are asked to sketch the graph of 25x squared plus 16y squared is equal to 400. Since we have plus, now we know that this is an ellipse. An ellipse and a central hyperbola, they are similar to each other. The major difference is the sign. So when you have a negative, it's a central hyperbola. When you have a positive, it is an ellipse. So you can write it in its normal form so that you are not confused, and also to help you know the intercepts, because it will give you the x and the y intercept. That is the advantage of an ellipse. Let's go ahead and plot it. Here is a Cartesian plane. You have your x and y. Then you also have your intercepts right there in the formula. Then you can just plot them and put them in your curve. For x-intercept, it will be 4 and negative 4. For y-intercept, it will be 5 and negative 5. Then you can carefully draw your curve. It should look nice, and try to make it look nice. It should not look like a funny amoeba, but it should look a little bit interesting. We have a follow-up question from the previous one. The question was asking us if this curve is symmetrical about the y-axis. Yes, it is symmetrical about the y-axis. As you can see, it is. In fact, it is also symmetrical about the x-axis as well. So this is a good follow-up question. You can see it on its features. We are yet again required to sketch the graph of y is equal to 3 raised by negative x. Of course, the position of x shows us what type of a curve this is. This is an exponential curve. Now, when we have a negative, it's the same as having a base of an exponent between 0 and 1. So that means it will look in an opposite direction as a normal exponent curve. So it will look right like that. The things that are important in a graph is number 1, the curve, number 2, the intercept, and number 3, the labeling of that curve. So this is what we are trying to show you as we do these many examples. We want you to be acquainted with those 3 things. They should be there. Just try to look at the equation and try to know how to draw that curve. Have a picture of that curve. Just compare the equation with the picture. The next question says, sketch the graph of x over 4 minus y over 3 is equal to 1. So this is a straight line because there are no squares, and it is given in a form where you can see their intercept. So you can see the intercepts for x is 4, then the intercept for y, it will be negative 3. Then that is how you can draw it with those intercepts in their correct positions. And then you just label the curve. That's it. We drew the curve, we have the intercepts, and we labeled the curve. That's all you need to obtain marks. In this curve, we will notice that we will not have the y-intercept because it's a central hyperbola. So this is how it will look like. We'll start with the turning point at the x-intercepts, both sides. Then there are few follow-up questions that are asked for this curve in particular. So for example, the first follow-up question they are asking is feature, what is it? Is it a function or a relation? Yes, it is a relation because if you put a vertical line, it will cut this graph in more than one places, which means it is a relation. It's one to many. Then the second question wants us to, it's asking, is it symmetrical about any axis? Yes, it is. It is symmetrical about both axes. In fact, about the y-axis and the x-axis. It was asking about the y-axis, but it is symmetrical about both axes, and also the domain. They want the domain for this curve. Your x must be less or equal to negative 10, and also it should be greater than 10. Then x also should be the element of real numbers. That will be the domain and the range for this curve. That will be the domain for this curve. The question says, sketch the graph of y is equal to negative square root 144 minus x squared. Of course, now we have a negative. That means we are focusing only on the negative side. That means below the x-axis. So this graph will only appear under the x line. Now we will look for the intercepts. So the square root of 144 will be 12 plus minus 12. Then you can just only take negative 12 for y, and then for x you take both plus and minus 12. So that will be your curve. It has intercept, it has the shape, and also we labeled our curve. Those are the 3 marks that you need for the test. The follow-up question is looking for the range of this graph. So that will be our range. So y will be between those 2 points, and then y must be an element of real numbers. Now moving forward or further, they want us to give the equation of the inverse function for this graph. Obviously, the first thing you do when you are looking for inverse function, just ask yourself that question: what do you want? What are you going to do? The first thing you do, you interchange the positions of x and y. So that means its inverse function will be x is equal to minus square root of 144 minus y squared. So that will be its inverse.